Hi, my name is Jay Chandran. Today I will be presenting this case study, which is about the combined cycle power plant electrical energy output prediction. So in this, the problem statement is like we need to build a model to predict the electrical energy output. And this is basically for the cycle power plant, which has a combination of gas turbine, steam turbine, heat recovery, steam generators, and so on. We have been provided with around 9,568 hourly average ambient environment readings from the sensors of the power plant. Now let's look at the kind of data we have been given with. So it has the temperature related data, the ambient pressure, and then we have the relative humidity, exhaust vacuum, and also it has also given the target variable, which is the output, the electrical energy output. On the right hand side, this is like a sample data. Few rows from the file which has been provided has been kind of depicted over here. Now let's go ahead and then perform some descriptive analysis on this data. So this is basically a univariate analysis. So here I have done an analysis of each of these variables which has been provided. So we can see the ambient temperature distribution, how the data is actually distributed. Similarly, we have for the exhaust vacuum, ambient pressure, and then the relative humidity. And also like the univariate analysis for the energy output is also there. So net what we see here is like the ambient temperature and the vacuum and energy output has a bimodal distribution. You can see like two distributions basically over here as well as in the previous slide. The ambient pressure that is normally distributed. The relative humidity has a little bit of right skewness. In both the slides, you can see like across the different variables, we don't see any outliers. Most of the data is actually within the range, so there is no need to exclude any data. So now let's look at like some bivariate analysis and see like how the data is actually distributed. So here this is a plot between the energy output and then the ambient temperature. Here actually we can see a very good kind of a trend line. You can see like as the temperature actually increases, the power output actually decreases. Similarly, we can see for energy output versus the vacuum. Here again, actually, we can see a kind of a negative correlation out here. Then when we see like the energy output versus ambient pressure, as well as like energy output versus the relative humidity, maybe this particular one, it may be trending upward. Maybe it can also be like put the other way, it can be trending downward as well. Similarly, we can see the bivariate analysis for output versus relative humidity. There is a trend line over here, but it's not very clear. Is it like really positive or it's kind of stagnant kind of stuff. So now let's look at like a correlation analysis, which also helps us to identify how the different variables are actually correlated among themselves. So here actually what we can see is like the ambient temperature versus the output energy. There is a big negative correlation. Similarly, the vacuum versus the output energy also we can see like a high negative correlation. Whereas when it comes to the ambient pressure and then the relative humidity, they are positively correlated that we can see, but it's not like very high. It's kind of 0.5 and 0.39. So that's what actually we can see. Now we can get into the modeling process and see like what is the kind of significance of these different variables when it comes to the model. So this is the model one. In this model, I have used Excel as the tool, and the model is the multiple linear regression. Initially for model one, I have used all the variables, all the four variables, the ambient temperature, the vacuum, the pressure, as well as the relative humidity. So after completing the model, what we can see here, we can see the regression statistics. So here the R square, you can see like close to around 0.93. And also like here, we can see that the p-value for the regression is actually 0, which is less than 0.05. So this model is pretty good. And here actually I have plotted the model metrics. It has like the intercept and then the coefficients for the different variables. So here we can see like from a overall regression equation perspective, we can see like this is the equation constructed with this coefficient as well as like the coefficient for the different variables. So the ambience temperature, you can see like since it is negatively correlated with respect to P, it has a negative. Similarly for vacuum as well, it is negative. And then here we can see like the ambient pressure is kind of having a positive influence on the output energy, whereas relative humidity is having a negative influence on the output energy. From the evaluation perspective, I have taken some 5 sample data from the test data, and we can actually see the output. So the residuals are like very minimal, like you can see like in the range of, let's say, somewhere around 2 to 7. That's the range we are seeing. And the standard error is also very minimal. If you can see like something like 4.6. So this model is pretty good. Now let's look at like alternate models. So this is model 2. Here what I have done is like I have removed one of the variables, which is the ambient pressure, and then tried to see like how the model actually performs. So after removing ambient pressure as well, what we can see is like the R square is like still it's very high, 0.93. So which essentially means that ambient pressure did not have a lot of influence when it comes to the output energy. So this particular model also we can see regression, it is kind of significance is like 0. So it's less than 0.05. So it is a significant model. And then we can also see like the standard error is also 4.57, which is kind of almost equal to the previous model, the model 1, which had all the 4 variables actually input as part of the modeling. Now the regression equation is actually constructed over here, and what we can see when it comes to the evaluation is like again the same set of 5 observations have been taken, and here we can see like the residuals are again ranging between 2 to basically 7. So this is also a pretty good model. Now let's look at the next model. Model 3, what I have done is like I have removed the relative humidity also from the model 2 and constructed the model 3. After doing that, we can see like the R square here, it is like close to around 0.92. So this is also a good model. And then we can see like the p-value is 0, again less than 0.05. So this is a significant model. And then what we can see is like even the variables like both the ambient temperature and exhaust vacuum, this also like p-value is less than 0.05. So these variables are again significant. And we can also see like the standard error. Standard error is like 4.97, which is also like pretty good. There isn't a lot of deviation out there. So again, the same set of 5 observations has been used for the model evaluation. We can see like the output or the residuals are just ranging between 0.7 to almost like 5.8. So let's look at like which are the best models and what can be recommended. So when it comes to regression, one of the good thing we can do is like we can plot the residuals. The residual plotting is basically like you plot your residuals against the predicted the output. So in this case, like we have the residual, which is basically the difference between what is the observed the output energy, what is and the predicted output energy. So that's the residual, and we plot it against the predicted output energy. So here what we can see is like since the residual plot is kind of evenly kind of distributed across the mean, and it is randomly distributed as well, which essentially means that the regression model is actually good. Now when it comes to selection of the model, what we see is like both model 1 and model 2, they almost have kind of equal R square and very low standard error. So either of the model can be used to predict the output energy. Model 3 is also good. If there is a situation where there is non-availability of, let's say, some of the variables like ambient pressure and relative humidity, then model 3 can be also used. So thank you.